Welcome to Maheshwari chemistry classes. Now I want to explain about RLVP. Before going to that, what is RLVP? I want to explain. So it is one of the colligative property. Okay. So here colligative property is first of all, what is colligative property means? Solute and solvent both are combined to give solution, right? Here solute is a non-volatile, solvent is a volatile. Okay, volatile means gaseous form. Okay, solute must be in a non-gaseous form, solvent must be in a gaseous form. Those are mixed with each other and give a solution. Here vapor pressure of solution, when these conditions are present, that time vapor pressure of solution is decreases. Okay, so for that purpose we have four properties. One is RLVP of solvent, relative lowering vapor pressure of solvent. Next, depression of freezing point solvent, elevation of boiling point for the solvent, or osmotic pressure of the solution. And this is one of the important properties RLVP. Now I want to explain that. Listen proper. Listen. RLVP, relative lowering of vapor pressure of the solvent. Okay, it is the ratio between lowering vapor pressure. Okay, so here vapor pressure of the pure solvent is P0. Okay, PS is after dilution vapor pressure. Okay, so P0 is a pure solvent vapor pressure. Okay, automatically this vapor pressure is high. Okay, next PS is after dilution. What is the pressure? That is less. That is why P0 minus PS we are taken. P0 minus PS by P0 we have to take. Okay, this ratio is known as RLVP, relative lowering of vapor pressure of the solvent. Okay, సింపుల్గా ఆర్ఎల్విపి అంటే ఏంటిదంటే ఫస్ట్ ప్యూర్ ఫామ్లో ఉన్నటువంటి వేపర్ ప్రెషర్కి డైల్యూషన్ అయిన తర్వాత వేపర్ ప్రెషర్కి వేరియేషన్ అట్ ద సేమ్ టైం ప్యూర్ ఫామ్ వేపర్ ప్రెషర్కి ఈ రేషియోనే మనం ఏమంటామంటే ఆర్ఎల్విపి, రిలేటివ్ లోయరింగ్ వేపర్ ప్రెషర్. ఓకే, వేపర్ ప్రెషర్లో తగ్గుదల కదా అదనమాట. సో అకార్డింగ్ టు రౌల్ట్స్ లా, RLVP of a dilution containing non-volatile solute, it is equals to the mole fraction of a solute. Okay, in this dilution non-volatile solute, okay, already you have an idea, solution equals to solvent plus solute, right? Okay, solute less percentage, solvent more percentage. Here this solute less concentrated, less percentage one is the non-volatile, means it is not gas. Okay, so that time this is equals to the mole fraction of solute. What is that? Mole fraction we have to take. Okay, so that is why P0 minus PS by P0 directly proportional to the X2. This is a mole fraction of solute. Okay, 1 is here taken as a solvent, 2 is taken as a solute. X2 means solute mole fraction. Now it is useful for molecular weight calculation. Okay, why it is useful? Molecular weight measuring purpose. That is why mole fraction of solute X2 equals to, okay, N2 by N1 plus N2. Okay, so once you check this, here I wrote, okay, N2 is number of moles of solute by N1 plus L2. Okay, 1 is for a solvent, 2 is for solute, right? So here we have to take solvent and solute. That is why N1 number of moles of solvent plus number of moles of solute N2. Then P0 minus PS by P0 equals, why it came here X2 nothing but here what we are taken P0 minus PS by P0. That is why here I wrote like this. Next, N2 by N1 plus N2. Okay, so according to that, for dilution N2 is less than N1. Okay, so that is why N2 is neglected to the downside. Finally we may get P0 minus PS by P0 equals to N2 by N1. N2, N means moles number, right? Moles number equals to weight by molecular weight. That is why in the place of N2, W2 by M2 here I wrote up. Okay, number 2 is for solute, right? So which weight, solute weight by solute molecular weight. Next, n1 is solvent, right? N means moles number. N equals to moles number equals to weight by molecular weight. That is why here W by M taken. Okay, for what purpose? N purpose. Next, N2 place W2 by M2, N1 place W1 by M1. Finally we may get this formula. It is very very important formula. M2 equals to W2 into M1 into P naught by W1 into P naught minus PS. According to this, we have one formula, we have one calculation. Sorry, listen properly. This is the problem. Vapor pressure of water at 293 K is 17.535 mmHg. Calculate the vapor pressure of the solution at 293 K when 25 grams of glucose is dissolved in 450 grams of water. Okay, so here once you check again, glucose is a solute. What is that? Glucose is a solute, water is a solvent. Okay, so that glucose, how much given? Glucose weight 25 grams given, right? Next, molecular weight, how can we calculate? We have to write the molecular formula. According to that, we have to measure. C6H12O6 is a molecular formula for glucose. According to that, individually if we count, we may get 180. Hydrogen purpose 1, oxygen purpose how much we have to take? 16. Carbon purpose 12 we have to take. Okay, so here based on that, simple like this. For carbon purpose we have to take 12, right? Weight 12 6 72 plus hydrogen purpose 1 we have to take, right? 1 12 12. Next, oxygen purpose what we have to take? 16. Atomic number 8, mass 16. 16 6 we have to take. Then 72 plus 12 plus 96. Then we may get 180 value. This is the molecular weight of a glucose. Later, solvent purpose water formula H2O. So according to that, molecular weight 8. Okay, actual weight how much given? Here 450 grams of water given, right? So here weight place we have to write like this. Then P naught already given. How can we measure? Vapor pressure of water at 293 K. How much? 17.535 mmHg. Okay, millimeter of mercury. That is the pressure units. Okay, then what we have to find? Pure form already given. After dilution, what is the vapor pressure we have to calculate? That is the PS we have to calculate. For that purpose, what we have the formula? This is the formula. Okay, P naught minus PS by P naught equals to. Okay, so what is that? Weight of solvent by molecular weight of solvent into molecular weight of solute by weight of a solute. Okay, in the place of what is that? Weight 1 purpose 25. Here molecular weight purpose 180. Here molecular weight purpose 18. Here weight purpose 450. Finally we may get value PS equals to 17.437 millimeter of mercury. Okay, it is very very important once you check properly. Okay, so these are the important questions. Learn properly. All the best.